Hello, today we'll be discussing growth hormone and its functions, its structure, and yeah, okay. So here we have a diagram of the pituitary gland. The pituitary gland is divided into the adenohypophysis or the anterior pituitary gland, which is in purple, and the posterior pituitary gland or the neurohypophysis. Growth hormone is produced um, growth hormone is produced via other stimulatory factors and inhibitory factors that encourages its release or inhibits its release. Okay, so up here, where we have this cross section right here, is the hypothalamus, and everything down below is the pituitary gland. Now remember, the pituitary gland sits in the sella turcica in the sphenoid bone. Okay, so the posterior pituitary, as we learned in neurology, the posterior pituitary takes electronic signals directly from the hypothalamus and it goes down into the posterior pituitary right here. Whereas the anterior pituitary is a relay system. So what I mean by that is we have a set of blood vessels right here. Okay, and then we have another set of blood vessels right here. Okay, so growth hormone releasing hormone is released by the arcuate nucleus in the hypothalamus. So this is the arcuate nucleus. The arcuate nucleus in the hypothalamus releases growth hormone releasing hormone. Okay, when this growth hormone releasing hormone is released, it then goes to the primary capillary plexus. So if the arcuate nucleus releases growth hormone releasing hormone, it goes to the primary capillary plexus. Now the primary capillary plexus relays this growth hormone releasing hormone to a special type of cell in the distal anterior pituitary called somatotrophs. So these are the somatotrophs right here representing green. Somatotrophs. So the somatotrophs receive the growth hormone releasing hormone. Okay, they receive the growth hormone releasing hormone, and via the CAMP system, so the CMP or cyclic adenyl monophosphate system, it causes CMP causes the somatotrophs to release growth hormone. Now growth hormone is the molecule right here. Growth hormone is a peptide hormone, just like prolactin. So prolactin and growth hormone are the two polypeptide hormones in the pituitary gland. So I'm gonna say this again. The arcuate nucleus releases growth hormone releasing hormone. Growth hormone releasing hormone goes to the primary capillary plexus, which then goes to the distal part of the anterior pituitary, where it reaches the somatotrophs. The somatotrophs are the cells that produces the growth hormone. So the somatotrophs release the growth hormone it releases the growth hormone when growth hormone releasing factor causes the release of CAMP, and CAMP causes the release of growth hormone, and growth hormone, like I just said, is a peptide hormone. Okay, after growth hormone is released, it goes into the secondary capillary plexus. So this was the first or the primary, and this is the secondary capillary plexus or the venous plexus, and it goes back to the heart, where it pumps growth hormone around the body to the systems that have the growth hormone receptor. Okay, so once growth hormone is circulating in the body, growth hormone binds to its receptor, growth hormone receptor, which is a non-tyrosine kinase receptor. Okay, so insulin is a tyrosine kinase receptor, but growth hormone is a non-tyrosine kinase receptor. So now we're going to talk about the functions of growth hormone. Like I said, growth hormone is an anabolic hormone. Okay, meaning it builds things up just like insulin. So growth hormone it's responsible for protein synthesis. It also has some catabolic functions, but it's mostly anabolic. So it has lipolysis, which is fat breakdown, and also causes insulin resistance. So it causes hyperglycemia. Okay, so like I said, growth hormone enters into the system, the circulatory system, and it causes these three main effects, where it can act indirectly or directly. So what I'm trying to say is growth hormone can undergo these three functions by binding to growth hormone receptor. So growth hormone itself binds to growth hormone receptor, or it can change to somatomedins in the liver, and bind to or insulin like growth factor, and it can bind to somatomedins receptor, but majority of the growth hormone function is by somatomedins. Now we're going to talk about the hypophyseal pituitary axis of growth hormone. So growth hormone is inhibited by feedback inhibition. So it's inhibited by growth hormone itself. Is inhibited by the somatomedins or the insulin-like growth factors, and growth hormone is stimulated by hypoglycemia. Remember, growth hormone causes hyperglycemia by causing insulin resistance. So it makes sense that hypoglycemia will increases its release. So let me just draw it here. Okay, so what stimulates growth hormone release is hypoglycemia, amino acids, because remember, growth hormone causes protein synthesis. Amino acids will stimulate it. Thyroxine. It is believed that thyroxine is required for growth hormone to work. Exercise also increases the secretion of growth hormone, because protein synthesis, we're building up muscles and bone. And also ghrelin. Now ghrelin is the hormone that is released when we're hungry. Okay, now we're going to talk about the simple pathology related to growth hormone. So growth hormone, if we have an excess in growth hormone, it can cause two conditions known as acromegaly or gigantism. Whether we have acromegaly or gigantism relates on the person's age or the age at which there is the increasing growth hormone. So if there's an increasing growth hormone before puberty, that is before the epiphyseal plate closes, then the child will have gigantism. Now, if growth hormone is in excess after the epiphyseal plate closes or after puberty, they have acromegaly. Okay, so with gigantism, there is increased linear growth of the bones, because the epiphyseal plate is not closed. So the child will be really tall. They will have something called as frank diabetes mellitus, because remember, growth hormone was responsible for causing insulin resistance. It can also cause hypothyroidism, in the sense that I also forgot to mention that growth hormone can inhibit TRH or thyroid releasing hormone. So growth hormone can inhibit TRH and cause hypothyroidism. And acromegaly, in the sense that it happens after puberty, we have wider bones, because the epiphyseal plates are closed. So if we had a bone right here, okay, let me just draw this bone. Okay, so if this was the child and the epiphyseal plate was still open, then we will have linear growth in this direction. But in adults, since the epiphyseal plate is closed, bone grows in width and not in height. So that's why in acromegaly they have a wider bones, wider teeth gaps, because the mandible, So if this was the mandible and this was the teeth in the mandible will be growing in width, creating something called as teeth gaps. It will spread the teeth out. Well, the illusion that the teeth are spreading out. It can also cause kyphosis, and more importantly, people with acromegaly tend to die of hyperlipidemia, hyperglycemia, and an enlarged heart. Growth hormone doesn't always only cause increase in muscle and bone. It causes growth and enlargement in all tissues. So this is why people with acromegaly tend to die of cardiomyopathy, with the triad of hyperglycemia, hyperlipidemia, and an enlarged heart. Also, people with acromegaly can also get carpal tunnel syndrome. They have an abnormal body odor. Their sweat glands, because their sweat glands hypertrophy, and also they have insomnia and colonic polyps. Okay, so, and the best way to test for increasing growth hormone is not by checking for growth hormone levels itself, because growth hormone is released in a pulsatile fashion, just like another hormone. Does anyone know? Gonadotropin releasing hormone is released in a pulsatile form. So if we were to check for growth hormone levels in the blood, since it's been released pulsatile, sometimes we can get a hormone concentration that is high or the hormone concentration that is low. So it makes sense that when we were checking for increased growth hormone levels, we check for insulin-like growth factor levels, or the somatometers. Okay, so this has been growth hormones, and I hope that was helpful. If this video helped you in any way, please give it a like, and if you watch my other videos and you seem to like what you hear or learn, please don't forget to subscribe. Thank you.